In this lecture, I'm going to solve a problem on amplitude transmissibility. Before that, we'll see the equations of amplitude transmissibility. So, just like the force transmissibility, the amplitude transmissibility is the ratio between amplitude of the base and amplitude of the structure. So, here B is the amplitude of the base. For example, if a vehicle is moving on a road, then B is the amplitude of the road and A is the amplitude of the vehicle. So the ratio between A and B is equal to root of 1 plus 2 eta r the whole square divided by root of 1 minus r square the whole square plus 2 eta r. So here eta is the damping factor and r is the frequency ratio. So r is equal to omega by omega n. In the case of resonance or when the vehicle is running at critical speed, then R value is equal to 1. Okay. So for a road profile, assume that the road profile is a sinusoidal wave. Okay. So the distance between maximum and minimum point is called as amplitude of the road. And the crest point between two adjacent cycles is called as wavelength, and the time to complete one wavelength is time period. Okay, so that equation for time period is equal to wavelength divided by velocity in meter per second. So if you substitute wavelength in meter and velocity in meter per second, then you will get time period in second. And we know that to convert the omega, the relation between omega and time period is omega is equal to 2 pi by time period. So it is actually 2 pi f frequency. We know that frequency is equal to 1 by time period. Then further, the omega radian per second is equal to, I'm going to substitute the time period here. So I will get velocity in meter per second divided by, so lambda is wavelength into 2 pi. So in case if the velocity is in kilometer per hour, then omega radian per second is equal to velocity in kilometer per hour into 1000 to convert the kilometer into meter, and this hour should be converted into second. So I am going to multiply 60 to convert it into meter and again 60 to convert it into second, further into 2 pi by del. So whenever you are calculating the natural frequency or forced frequency, in the case of vehicle speed, then you have to provide the solution in kilometer per hour. Okay, so if you want to convert the radiant into kilometer per second, I mean kilometer per hour, you can use this relationship. Okay, so now we'll move into the problem. A vehicle of mass 490 kg and total spring constant of its suspension system is 60 into 10 power 3 Newton per meter. The profile of the road may be approximated to a line curve of amplitude 4 centimeter. So the amplitude of the road surface is given, and we know that the amplitude of the road surface is B when the vehicle amplitude is A. Okay, so it is given in centimeter. I have converted it into meter. So B is equal to 0.04 meter and a wavelength of 4 meters. So the lambda is given, lambda is equal to 4 meter. Determine the first one, the critical speed of the vehicle. Then second one, the amplitude of steady state motion of the mass when the vehicle is driven at its critical speed and the damping factor is 0.5. So damping factor is 0.5. So here we have to calculate the amplitude A when R is equal to 1 or when omega is equal to omega n. Then the third one is the amplitude of steady state motion of mass when the vehicle is driven at 57 km per hour. So here the forced frequency is given. So V is equal to 57 km per hour and the damping factor is 0.5. So here we have to convert this V into, I mean kilometer per hour into radian per second using the equation what I have shown in the previous slide. So we'll start from the critical speed of the vehicle. We know that the critical speed means omega is equal to omega n. Further, omega n is equal to root of k by m, and in the problem the k value and m value is given. So you can substitute it and you can calculate the value of the critical speed of the vehicle. Okay, so here the omega, that is critical speed, is 11.06 radian per second, and we have to find out the velocity, because whenever you are specifying the speed of the vehicle, then you have to specify it in the kilometer per hour, not in the radian per second. So I am going to use the relationship between omega and velocity. So omega is equal to velocity, that is speed in kilometer per hour, into 1000 divided by 60 into 60 into 2 pi by lambda. So omega is 11.06, speed in kilometer per hour is v, then 1000, 60, 60, 2 pi, and the lambda is given as 4 in the problem. Okay, so if I solve this, then I will get the velocity, that is 25.36 kilometer per hour. So this is the critical speed of the vehicle. Okay, so this is the first division. Then the second subdivision is amplitude of the vibration at resonance, that is at critical speed. We know that at critical speed or at resonance, the R value is 1. So you can write the amplitude ratio and you can put the R value as 1, and the damping factor is given as 0.5. Further, the amplitude of the road surface B is given, it is 0.04 meter. I can substitute it. Remember that A is the amplitude of the vehicle and B is the amplitude of the road surface. So if I solve this, I will get A is equal to 0.05 meter. So this is the second subdivision. And the third subdivision is amplitude of vibration at V is equal to 57 km per hour. So this is actually omega, that is forced frequency. But we have to substitute the value of omega in radian per second. So we need to convert the omega value into, kilometer per hour into radian per second. So I am going to use this relation to convert the kilometer per hour into radian per second. So you can substitute the value of velocity, that is 57 km per hour into 1000 divided by 60 into 60 into 2 pi divided by the lambda is 4. So if you substitute the velocity in kilometer per hour, then we will get omega in radian per second, that is 24.86 radian per second. Okay, so when the vehicle is moving with the velocity of 57 km per hour, then the forced frequency will be 24.86 radian per second. Now by using the omega and omega n, I can calculate the frequency ratio, that is omega by omega n. It is 24.86 divided by 11.06. So R is equal to 2.247. Now what I am going to do is I am going to substitute the R in the amplitude ratio equation. A by B is equal to, B is the amplitude of the road surface, I can substitute it. Then in the place of R, substitute 2.247 and eta is equal to 0.5. Okay, so if I solve this equation, then I will get A is equal to 0.02 meter. This is the amplitude when the vehicle is moving at 57 km per hour. Okay, so first we have considered the resonance case and we have calculated the amplitude of the vehicle. Then the second is, by considering the vehicle is moving at 57 km per hour, I have calculated the amplitude. Okay, so the tutorial problem. A trailer has a mass of 1000 kg, so mass is 1000 kg when fully loaded, and 250 kg when empty. So two cases are given. The first case is the mass is 1000 kg, and in the second case the mass is 250 kg. The spring of the suspension is 350 into 10 power 3 Newton per meter. The damping factor is 0.5, that is eta is given, k is given. The speed is 100 km per hour. So speed is given in V, that is kilometer per hour. Convert it into omega, that is radian per second. The road varies sinusoidally with the wavelength of 5 meter. Lambda is given. Determine the amplitude ratio. So here we don't need to calculate the amplitude. We need to calculate the amplitude ratio, that is A by B when fully loaded and mt. So which means A by B when the mass is 1000 kg, that is first case, and A by B when the mass is 250 kg, that is second case. So you have to split the problem into two. One is mass is equal to 1000 kg and another one is mass is equal to 250 kg. Okay, so calculate the A by B value for each cases. And the solution is for fully loaded condition, A by B is 1.45 and for empty the A by B value is 0.65. So this is how we have to solve the problems on amplitude transmissibility. And in amplitude transmissibility, mostly you will have problems from the vehicle suspension system. Okay, so you need to convert the kilometer per hour into radian per second. So just remember that equation to convert the kilometer per hour into radian per second, or to convert the radian per second into kilometer per second. So once if you convert the v value into omega, then the remaining problem will be similar to the force transmissibility. Okay, so in the case of force transmissibility, we have to use ft by f, but here we have to use a by b.